just a quick introduction to me. I'm the Xen contributor responsible for maintaining the Argo subsystem. I've been an OpenXT contributor and a maintainer for Xen in Open Embedded. And one of the questions I get asked is, what is Argo? Which led to the topic for this presentation. Because explaining what Argo is not particularly easy. It's a multi-component technology, and the answer is it's an architectural technology. So I was hoping to talk to you guys today about building an architectural technology for Xen. So explain what an architectural technology is. A thing that contributes to the design of an overall system, enabling distribution of components, how they connect and how they communicate. It's more complicated than just an individual component, which makes it harder to describe, harder to build, and more complicated to develop and maintain. So having figured out one of the reason explaining what Argo is because it's an architectural technology, I then thought that it turns out that describing open source architectural technologies is a very large topic. It's worth Googling. There's a lot of it out there. So narrowing the scope for this, I thought I'd just talk about Argo as an example of an architectural technology to kind of illustrate what was involved in developing it, what it enables, and what's interesting about building an architectural technology with open source. So just to give context what Argo is an interdomain communication mechanism. It's an implementation, but also the protocol for communicating between guest virtual machines. It's implemented with a core implementation in the hypervisor of a hypercore with simple but powerful primitives, and it's been designed to maintain security properties. Its implementation is providing strong mechanisms for use by guest virtual machines. So in order to use this in a system, you have the hypervisor component, you have the Linux kernel device driver that is responsible for invoking hypercores to the hypervisor, and you have a Linux user space library that enables applications to map their networking config and communication paths onto Argo as a transport. And the things that make Argo distinctive from other interdomain communication options that you have, either on other platforms or with Xen, that it is designed for these security properties of maintaining data isolation, not relying or requiring any shared memory between VMs that are communicating, and it's preserving isolation between those VMs by performing data copies. And those data copies are performed by logic implemented in hypervisor, which is within your TCB. So you have more confidence that the actual movement of data from one virtual machine to another adheres to the transfer protocol that you're expecting. You know, data is moved once, it moves into the buffer where it's expected. It's delivered synchronously when the send operation is invoked. And all of this is governed by the system mandatory access control policy that's enforced by the hypervisor. It's integrated in Flask. It governs what communication paths are allowed, which VMs are allowed to invoke the data transfer operations. So that's Argo described very quickly. And these are the open source components that it comprises. There's the logic in the hypervisor, there's the Linux kernel device driver, there's user space library. There's also aspects for testing it in the Xen test framework and the Xen CI system. Each of these have their own open source components that have Argo integration. Then there's Linux distro integration. There's both Xen and the Xen test framework have integration logic inside the open embedded meta virtualization layer, and that's cross architecture. That's both Xen and ARM. Sorry, both x86 and ARM are integrated for Xen. There's additional pieces for building your Xen systems, the multi-config support in Bitbake and Meta Argo if you actually want to enable Argo specific logic in your Xen builds. That's got integration logic there as well. And then we have documentation, which lives in several different places. There's some of the design documents are in Xen source control. There's documentation on the Xen wiki, the OpenXT wiki, there's developer notes, and there's prior Xen Summit presentations describing all of this. So there's a lot of different components. They're all open source and they're maintained in different places. And these are all things that you have to reason about when you are coming along as a potential user for Argo. If you're looking to actually do your integration, these are things that you'd have to be familiar with. So describing how Argo is enabling system architecture, this is a diagram of the basic communication, two-way communication between two VMs, and you've got each of these components in use. You've got the hypervisor in the log at the bottom. You've got per VM access control policy implemented in XSM. Within each guest, there is a kernel and a kernel driver, and you've got the user space libargo enabling the app to make use of the kernel interface. And the kernel makes use of the hypervisor interface. And what I wanted to show here was that there's when data paths are established between the two VMs, you've got data structures inside the Linux kernel for tracking the individual connections, and then you've got rings within the hypervisor where the individual communication paths are maintained in a table within the hypervisor. That's kind of you. So if somebody asks what is Argo, you have to kind of, if you want to actually point at it, you've got a number of different components here, each of which has got its own arena for development and maintenance. So the slide here is just showing, the system architecture can get more complicated, and you're still using the same simple Argo primitives, just in a different combination. You've moved, for example, in this case, we've got an HVM mode guest VM, where with a subdomain device model, where the actual guest VM may have no Argo components in it at all. They could all be inside the device model that is using Argo to communicate with a backend in the hardware domain. So you've got, again, user space, kernel, and hypervisor components, but they're integrated in different system images, and your communication paths between the different VMs will be different in this case, and your QEMU logic is likely informed about Argo. It's Argo aware in order to be able to establish communication with the toolstack or backend software in your hardware domain. Your system architecture gets even more complicated when you've done your hardware and control domain separation. But again, all this can work, and there isn't a need to make changes to the hypervisor implementation. It's largely configuration and integration logic that then able to build this more advanced architecture, still using the same communication primitives. So what we have in this slide is this is a diagram showing how the data operations, when you're communicating from that guest VM to the hardware domain, from like this slide or this slide with this architecture, this is how the data buffers are actually accessed. Your guest VM is invoking the Argo hypercall that is mediated by XSM Flask, and if it's allowed to transmit, it writes into a hypervisor mapping of a buffer from the hardware domain. So when that completes, the data is visible to the hardware domain. It's able to perform its physical I/O and send a message with a response in the reverse direction, which again is mediated by the hypervisor. It goes into the hypervisor's mapping of the guest VM front end's buffer, and the data is available when that completes. This is a more advanced way of using Argo for virtual device buffer access. So the previous slide, this system is rather simple. It's one buffer to transmit, one buffer to receive. This is a diagram showing how VirtIO can actually communicate using Argo by using two separate uses for the buffers here. We're invoking one Argo operation to transmit data from a guest buffer into a receive buffer, but there's a second transmission, since this is conforming to VirtIO, where we have Argo rings mapping over the existing VirtIO split device driver rings. It's a means of blitting the VirtIO data structures from the front end to the back end, so that all of the descriptors are available to both sides. It's a way of avoiding the need for shared memory between the two, but it also ensures that all of those operations are also subject to access control. Whenever you need to perform a send, the data transmitted is mediated, but so is the update to the VirtIO data structures, and it hooks into the existing structure of VirtIO rather nicely. This was the design for a VirtIO Argo transport driver, but I actually think that following Bertrand's talk earlier today, this same principle could work rather nicely with the VirtIO message design. So I'm interested in attending the design session to talk about this. So again, the point with the architecture here is that actually quite complex operations and system architecture can arise and be implemented with the exact same simple primitives in the hypervisor and some careful design in the Linux device driver side. So at the moment, what we have is this is the distribution of components between the major communities that Argo has developed in. In the Xen community, we have Argo included in the hypervisor. got design documentation and test system integration, both in XTF and in Xen's continuous integration. And there's a reference XSM policy for describing Argo communication and configuring it. In the OpenXT community, that's where we currently have the current Argo Linux kernel driver. There's also prototype one, and there's interest in developing an additional set there at the moment. OpenXT community is also where the Linux user space library is, and there's some developer documentation. And for those who really want to dig into the intricates, OpenXT itself has some additional specializations. There's use of Argo for audio and a TAPI pass through with QEMU. So there's some patches there, but that's really specialized for OpenXT and its downstream use cases. And then in the Open Embedded and Yocto community, there's work for integrating Xen and XTF there, and there's an additional layer for if you want to do the Argo enablement in your Xen build. It makes it easier, avoids you having to apply your own config. So there's these different arenas where the development happens, and a major activity in working on this takes place when there's transfer from one community to another. So this slide here, I'm aiming to show the movement of code and logic and the implementation from the original proprietary work done at Citrix into the Xen open source tree took multiple stages and involved quite a bit of work. So let me talk you through this. The time, the earliest stuff is in the bottom left-hand corner, and the most recent stuff is in the top right. So we have the original development of the software in multiple iterations at Citrix. V2V was the initial version, and after learning from that, V4V was the new implementation. And that was part of a proprietary product at Citrix that was then released as open source to the OpenXT project. So in the third column, moving upwards, that's the V4V OXT version. There's also a version that went to HP Bromium into their proprietary product, and that was separately released as open source rather later in the Xen open source release. So there's a version of V4V as Argo was initially developed in the Xen hypervisor, and then there were multiple rounds of submitting V4V to Xen with a lot of feedback provided and development work that had to be done to make it suitable for inclusion. So what happened was with V4V still having a life within the proprietary Bromium HP software and in the using open source, it didn't make sense to use the same name for the variant that was being developed for Xen, since it was different with different operations and different interfaces. So that's why we renamed it to Argo. And Argo was developed by the OpenXT community, taking effectively the best of breed from each of the Bromium Xen version, the multiple submissions to the Xen mailing list that had been prior, and also the active OpenXT version were all combined and refined before beginning iteration in the Xen community, where multiple rounds took place to build this version of Argo that was suitable for inclusion in Xen, and that went in Xen 4.12, and that's where it's maintained now. So this was effectively a multi-path route from the original development into the software that's included in Xen, and that's just the hypervisor component. There's also the Linux kernel software, which has a even more a longer path, and its destination is ultimately the Linux upstream. So there's work here. There's the initial Citrix version. There's the Bromium and the Xen variants. There's the OpenXT development, and then there's the porting back after Argo was merged into Xen. Modifications that went back to the Linux driver to bring it into alignment with upstream Xen Argo. And there is now an interest in a new set of Linux device drivers built on Argo, but built upon the Xen driver suite, since it's had considerable investment in being deployed with the HP Chromium product. It's a good piece of software, and the aim is to build a new set of Linux drivers using Argo suitable for upstreaming into mainline Linux. And I think Daniel has possibly some time to talk about that tomorrow. So looking at this, looking back at all of the work that was done on the many components of Argo in their different arenas. I mean, I haven't even described that there's also development on Xen test framework, test case. There's separate development by the team that got Argo into the Xen CI system. In all of these different places where the work is done to move it forward, the details improve and the designs advance and become more refined, the code quality raises. All of these are beneficial aspects of this being code that lives for an extended duration and is worked on in the open and has many contributors across multiple communities. It does have complexity in maintaining these disparate components in disparate places, but there are major benefits to doing the work that it takes to get it upstream. A major one being that, you know, V4V was developed as an x86 only technology. It's now compatible with ARM by virtue of taking it into Xen. And the reach of this technology is much broader through having been included in Xen. It's a major motivation for doing the work that it takes to get it upstream. So yeah, there are motivations for upstreaming are many. The approach is different for the different components. Some communities are very open with their and friendly with their feedback. I don't know that going to the Linux community first would have been the right choice. Definitely the Xen community has been very approachable and the feedback has benefited the software a lot. The processes involved are different when you're taking software upstream. Downstream software is typically maintained in patches, cohesive large patches, and submitting that code upstream requires breaking it up into smaller individual patch series with negotiations and proposals and discussion and iteration. There's their own communication patterns involved with doing the work to take it upstream. It often involves seeking out maintainers, trying to understand what their priorities are, what their areas that they care about, that you need to make sure are in good shape. And that feeds back into development downstream as part of readying your work for upstreaming. I think the experiences are broadly positive. I mean, definitely it took Argo a number of rounds to be suitable for inclusion in Xen. But I think there are educational parts to all of that development. And a critical thing in supporting all of this is the resources, the open source resources, the platforms, the wikis, the documentation, the public repositories, the public CI systems. There's a lot to learn about the individual tools you have available as part of doing the upstreaming work.
Christopher, just a time
Sorry?
check.
Okay.
A time check. We have 5 minutes left.
Okay. Thank you. I'll go quickly. Um, so yeah, for future developments for Argo, we're looking to be, documentation to support the adoption of Argo with new downstreams through Xen. There's interest in hypervisor work towards Xen's new ABI. There's activity with the new suite of Linux Argo drivers looking to be developed for the kernel.org, kernel based on the Xen code base. The open embedded meta virtualization layer has Xen integration. There's real potential for some useful work there with multi-config and Argo enablement. There's also I think the Virtio work being done in the Xen community could benefit from having some discussions around Virtio Argo. I'd like to pursue that. I'm hoping to engage in the design discussion at the summit. As far as stepping back from Argo as a specific, looking at open source architectural software development, it's really noticeable how the open community platforms are essential for sustaining the long-term development of the open source software. So as I mentioned, the source repositories, issue trackers, documentation, mailing lists and forums really make a difference. I didn't include design sessions on here, and I should have done. Summits and design sessions, very useful. Also, things that matter over time when you're maintaining an open source architectural technology is engaging with new developers and communicating to passing down the knowledge as people transition, people move. Leadership and mentoring matter a lot, and the tools and technology and platforms you select for doing your work affect people. So using tools that people like to use that are modern and appealing makes a difference to your developer pool. So I've included some references for those of you who are interested in the slides. They're uploaded to Shed for access afterwards, but I don't really want to go through those right now. But could I answer any questions? It is the last talk of the day.
Just one question. From the mere existence of the talk, I understand that Argo is intended to have a future. Since there hasn't been a lot of work in that area, I was actually wondering what the situation with it is. If I remember correctly, it still isn't fully supported in the hypervisor.
That's correct. Yes. So there is recent interest in Argo. There's been contributions from AMD's linked to the CI system, and it's an important piece when used alongside Hyperlaunch and Trench Boot. So there has been more development activity on both Hyperlaunch and Trench Boot than Argo lately, but the ability to use Argo, I believe it would be likely to see more activity once Hyperlaunch is in a state where using Argo for your device drivers would make sense.
Okay, so more concretely, are there plans to get Argo into fully supported shape?
There are not concrete funded plans that I'm aware of at this point, but I do think that there is sufficient.
The question really is, much like TMEM in the past, TMEM was put in the hypervisor, was living there for like 10 years, and then maybe it was just 8, and then was taken out again. If the same shouldn't happen to Argo, it will need to move to fully supported state at some point.
Yes, I think that's fair.
Okay.
I think to a certain extent we could have this discussion possibly after the VirtIO meeting design session tomorrow, because I'm genuinely interested to see whether or not Argo is a good fit for some specific use cases with VirtIO.
Yeah, I do agree, Christopher, that there is a Argo could solve one of the initialization problem for VirtIO message over Xen, meaning that we could use it to transfer VirtIO messages. So it could fill the gaps, and we should discuss this during the design session.
Okay.
And definitely there could be also a way to use Argo with VirtIO message to achieve a fully secure VirtIO stack by using your DMA engine. So there is a good solution there that we need to look at. Definitely.
Excellent. Thank you. Thanks.
I would just add the comment, we've got Argo deployed in hundreds of devices for years now. So what is the criteria for it to become supported, right? We keep saying this and I keep asking the same question. What is the bar that you want us to cross to move it into its supported state?
I think to be supported, it needs to be used. Another first thing. So if we find a way to make it a value proposal, then there is a path for it to be supported. And definitely if we have a full stack integration because we use VirtIO message on top of Argo, by defining a new VirtIO message bus over Argo, like we did for FFA, the technology is useless if it's not used. So we need to find a use case for it.